Welcome to Statistics for Marketing Math 1080. We're going to have this first lecture and we're going to mainly focus on levels and types of data, but first I want to do a little bit of an introduction. So welcome to the world of statistics. Most of you are here because you have to take this course. It's part of your next steps or your graduation. But don't write off this opportunity quite yet, because statistics can play a very important role in your life. Everyone is a consumer of statistics, and as a marketer, you live and die by them. We're continually surrounded by data and statements that are meant to influence everything you do, the choices you make, the purchases you make, change your opinion, and so on. When Global Sports announces that 11 million viewers tuned into the Blue Jays game last night, do you know how they determined that number? When you hear that the Prime Minister's approval rating is 26%, and then in small print you see plus or minus 4, do you understand the significance of this? Because it is very important. When you read an advertisement claiming that a new product is recommended by 4 out of 5 doctors, do you critically think about that? Worry about the validity of the claim? If that's your marketing campaign, are you concerned, and you should be concerned, about the validity of that claim? When an online survey reports that Canon digital cameras are preferred to Nikon, it should concern you about how they obtain the results of that survey. So, for example, did they only interview Canon users? All of these are important questions in statistics, and take a look at this video for us. So statistics are important. Never before has there been as much data and information available at your fingertips. Statistics have a powerful effect, nothing else that target example should show you. As a result, it's very important that we report what is both accurate and unbiased. In this course, we're going to be dealing with business statistics. What is it? It's a mathematical science that deals with that collection, the analysis, and presentation of data. So business statistics are statistics applied to the business world, and we do that in order to improve decisions, whether it be decisions on marketing, operations, finance, human resources, all of those. But we need more data. We need more than that. Data is just raw facts and figures. We need information to make those decisions. So that's what we're going to be doing in this course. We're going to derive information from those facts and data in order to make those decisions, and then it's going to be necessary to transform our statistics into information. So we're going to study two different types of statistics in this course. We're going to have descriptive statistics and inferential statistics. Descriptive statistics are methods that are needed to organize, summarize, and present data. This will reveal basic patterns in the data, allow us initial calculations for the foundations for further analysis, which is inferential statistics, and we're going to take that information and reduce it, called data reduction. So we're going to talk about the mean, the median, the mode, skewness, range, and standard deviation of data, and then we're going to take that information and work on inferential statistics, and that's methods used to estimate the characteristics of a target population. So we're going to base that on samples or surveys, and we're going to be doing confidence intervals, hypothesis testing, and regression analysis. We're going to use this information to analyze that data to make business decisions and research. First, we need to have some information. When we're dealing with statistics, there are two very important distinctions. Number one is the population that we're looking at, and number two is the sample. So the population is a statistical study of the complete set of things or beings that you're interested in. So if we wanted the weight of every Fanshawe student, we would have to have a population of all 23,000, maybe more. However, if we were just looking at the students in Math 1080, that would simply be our population, just those students in Math 1080. A sample is a subset of whatever population that you have. So if we were going to find the weight of 1,000 of those Fanshawe students, and of course a sample hopefully is representative of that population. That's the whole intention. A parameter is a summary measure of that population data. So mu is the entire population average, the average weight of all those 23,000 Fanshawe students. A statistic, on the other hand, is the measure of that sample data, so the average weight of those 1,000 Fanshawe students. So data is the foundation of statistics, and we're going to look at the different types of data that we will be dealing with. Data are values assigned to a specific observation or measurement, and there's many different ways that we can look at data. For example, say we wanted to collect the data on the snoring of one's parent. We could measure how many times they snored in 5 minutes, or we could measure the length of each snore, or we could measure how loud each snore is. These are all the same event, but in a different form of data. The first is a frequency or a number count. The second is the duration or length, also a number count. But the third is a description. It's not involved in numbers. So your data of interest is often called your variable. So the variable here would be the frequency, how long, how many. The second would be the duration or length. The variable is the duration or length of the snore. And the third would be a description. What does it sound like? But it's still all a variable. So you can see the types of data are two types of data. The first one is a qualitative data, and this is just describing the quality of the data, what it looks like, what it sounds like, and so on. And there are two types of that. One is nominal, where we're not going to ranking. We're just going to name them. And the other is ordinal, where we will be ranking the type of descriptive data that we are looking at. And the second, of course, is a quantitative. That's when you count or measure. Your data is counted or measured. And that count or measure can be discrete or it can be continuous. And quantitative can be further divided into an interval. Ratios do not apply, or a ratio. And we'll talk about each of these and then do some practice. But keep this in mind, this data measurement flow. There's only two types, qualitative and quantitative, and each of them have two subcategories. But quantitative can be discrete numbers or continuous numbers. So, qualitative versus quantitative. Qualitative values that can be placed in non-numerical categories, sometimes called categories. So your eye color, if your variable of interest is eye color, then we have blue, brown, green, etc. Star ratings of restaurants. It's really just a description of the restaurant, even though you can have 1 star, 2 star, 3 star. Don't get confused by the numbers involved in that. It's just a description. Necessarily could be good, bad, and ugly. A quantitative data, well, that's a numerical representation of the data. It's a count or measure. So the finishing times of runners in a race, the income of college graduates, the number of people who attended a game. So take a moment and try and classify each of these questions. The brand names of shoes in a consumer survey. So you're just talking about brand names, right? Nike, Adidas, and so on. So this is just simply a qualitative data. We have scores on a multiple choice exam. So you're wanting to know what you got, 15 out of 20 or 10 out of 20. It's a quantitative. It represents a number of correct answers. Letter grades on an essay assignment. It's simply ranking them, but it is describing how well you do, so it's qualitative. It represents different categories of performance from passing to failing. Numbers on a uniform that identify players on a team. So we are using numbers, but it isn't in any way counting them. It's just saying that is number 9. It describes that player, so it's qualitative. It does not represent a count measure. When you have quantitative data, you can have it either discrete or continuous. So discrete data is only particular values in an interval, so 1 or 2 or 3. The number of students in this class, well, you can't have a 1.1 student. You either have 1 or you have 2 or you have 3. Even if you're asleep, you're still a whole number. There's no values in between. Whereas continuous data, even though it's a number count, there are values that are possible within that interval. So a person's weight can be between anything between 0 and a few hundred pounds, but in between each of those pounds is continuous data. You could be 1.1395 pounds, 1.1396 pounds, and so on. So let's look at quantitative data and examples of discrete or continuous. So measurement of the time it takes to walk a mile. Well, this is going to be continuous because time is continuous and flowing on that, and there are intervals in between. The number of calendar years, so such as 2007, 2008, 2009. Well, this is discrete. We don't generally say it's 2009 and a half. We say it's just 2009. So it's discrete. It doesn't have fractional values. The number of dairy cows on different farms. Well, you have a whole dairy cow or you don't have a whole dairy cow. It's a discrete number, so it's discrete. The amounts of milk produced by dairy cows on a farm is different. Whether you do it by weight or volume, there is going to be continuous values within 1 liter to 2 liter or 1 kilogram to 2 kilograms. Levels of measurement, qualitative. When we have qualitative data, we can have nominal level data, which is qualitative, or we can have ordinal level data. So in nominal level data, we're not going to rank in any way. They're just labels. We're saying they're Nike shoes or Adidas shoes and so on. Again, is blue eyes better than green eyes? Is male better than female? Brand of shoes and so on. Those are all just naming. And this might be a survey question. So for example, what type of shoes do you wear? You want to find out what's the most popular brand. Categories and labels are ordinal level and they're used to rank. So you're just still describing. It's a qualitative, but you're still describing. So our classic restaurant ratings, 1 star, 2 star, 3 star, is qualitative, but it's ranking them. So it's an ordinal level of the qualitative data. Good, average, or poor in terms of restaurants or service, letter grades, and so on. Interval level data, there are different measurements for the quantitative data, and that would be interlevel data. And in this case, numbers are used, of course, because it's quantitative. And they're a scale or a ranking system, and it may have a value of 0, but not a true measurement of 0. 0 does not mean nothing. So you can have 0 in clothes sizes, but it's not really nothing. You still have a dress or you still have pants, but it doesn't mean 0. And finally, ratios have no meaning. So shoe sizes, for example, are numerical, but you don't really have half sizes in terms of shoe. A size 6 shoe is not half the size of a 12 shoe. They are just simply letters that are applied to it. You also don't have a 0 size shoe, and if you did, it would still be a shoe. It would just not mean nothing. So that's interval level data where ratios don't mean anything. Let's look at an example of Fahrenheit, for example. A scale of 40 degrees is not really half of 80. We also have quantitative data where it's ratio level. In this case, ratios actually mean something. So again, numbers are used because it's quantitative data. But 0 here is truly means 0, means nothing. There is nothing there. So when we have a start of a race and you're timing on a race, 0 means you have no time, you haven't started yet. Ratios in this quantitative data ratio level, they have meaning. So 5 kilometers is actually half of 10, or 30 minutes is half of 60, or 40 kilograms is twice the amount of 20 kilograms. Ratios do have meaning with ratio level data. So again, we have 2 types of data, qualitative and quantitative. With the qualitative, we have 2 types. We can have a nominal or an ordinal. So with nominal qualitative data, you're simply describing the quality of some variable, some characteristic of interest, and there's no ranking. They have blue eyes, they have green eyes, they have brown eyes. With ordinal, you're still describing a quality, but it is ranking them. So this restaurant's a 1 star, this restaurant's a 2 star, this restaurant's a 3 star. You're ranking them, but still describing. With quantitative data, it's numbers. You're counting or measuring something, and you can measure discretely, so each individual, 1 person or 2 persons or 3 persons, 1 cow, 2 cows, 3 cows, or it can be continuous in terms of there's a flow of data in between 2 whole numbers or values. So the amount of milk, you could have 1.5 liters, 1.25 liters, 1.3 liters, 1.9, and so on. Quantitative also has 2 further breakdowns. One is the interval level data. Temperature is an example of this. In these, you have a counted measure, but 0 does not mean 0. So when it's 0 outside, it doesn't mean there's no temperature. It just means that it's freezing, 0 degrees centigrade. And ratios do not apply. 10 degrees is not really half of 20 degrees. And size 6 shoe is not half of a size 12 shoe. Then we have ratios. Ratios start at 0. You have a real 0. 0 means nothing, no time, no measurement. And ratios are also relative in terms of 5 kilograms is twice as much as 2.5 kilograms. 10 minutes is half of 20 minutes, and so on. Let's do some examples. Listings of cities visited. Qualitative and nominal. Qualitative, we're just simply listing cities, and we're not ranking them in any way, we're just naming them. Qualitative and nominal. Types of housing available. Mansion, townhouse, so on. Again, it's going to be qualitative and nominal. We're just listing them, we're not ranking them in any way. Number of bedrooms in a residence. This is going to be numbered. You're going to count the number of bedrooms. So it's definitely quantitative. Is it discrete? Yes, you can only have 1, 2, or 3 bedrooms, or so on. And is it interval or ratio? Well, you have 4 bedrooms, that's twice as many as 2, so it's going to be quantitative and ratio and discrete. Attendance at home games. Number of people that are at a home game, well, that's going to be quantitative. You're going to have discrete because there's 1 or 2 or 3 people, you don't have half a people, and it's going to be ratio because 10,000 people is twice as many as 5,000 people. Quantitative, ratio, and discrete. Weight of packaging. Again, we're talking about a measurement, so it's going to be a quantitative data. It's got numbers associated with it. We know that there are values between 1 kilogram and 2 kilograms, so it's going to be continuous. And it's ratio because 2 kilos is half as much as 4 kilos. So quantitative, ratio, and continuous. Listing of faculty names. Here we're just going to be listing the names of professors, so it's no numbers involved, so it's qualitative. And we're also not going to be ranking them in any way, we're just going to be naming them, so it's qualitative and nominal. Number of years of employment. That's going to be a numerical, so quantitative. There are, generally speaking, we don't say we have 7.25 years. Sometimes we might say 7.5, but generally it's a discrete, and it's not, 4 years is is half of 2, and so we have ratios that do have relevance, and 0 years of employment is 0. So it's going to be quantitative and ratio and discrete. Shoe size. Well, we've already done this one. We know it's going to be quantitative. We know it's going to be interval because a size 0 shoe is still a shoe. And it's going to be discrete because you have 9.5, but you don't have values in between those. Letter grades. Again, we've done this. It's going to be qualitative and ordinal. It's qualitative, describing the quality of your work, and we are also ranking it. Distance traveled to work. Well, again, this is a measurement, so it's quantitative. There's going to be value in between each 1 kilometer and 2 kilometers. There's going to be values so it's going to be continuous, and 2 kilometers is twice as far as 1 kilometer, so it's going to be ratio. Ratios mean something. 0 distance traveled is 0 distance traveled. It actually gone nowhere. Heights. Same thing. Same thing exactly. We're going to have quantitative, ratio, and continuous for all those same reasons. Temperatures. This is, again, an example we've looked at. It's going to be quantitative because it is numerically based. However, 0 does not mean 0 temperature, so it's going to be interval. And it's discrete. It is continuous because there are values between 1 centigrade and 2 centigrades that are relevant. Service, good, fair, poor. Again, we've done this one. This is going to be a qualitative. You're just discussing the quality of the service, and you're ranking it, so it's going to be qualitative and ordinal. Makes of Ford vehicles. You're not in any way ranking them, you're just saying it's a Ford vehicle, types, and so it's going to be qualitative and nominal. Number of customers served. Well, the number of customers served is quantitative. It's going to be discrete because each person is an individual person and there's no values in between 1 and 2 people. And then you're going to have discrete and ratio because 2,000 people served is 1/2 4,000 people served. Finally, we also did this one, numbers on the shirts of baseball players. They are numbers, but it is a description of the baseball player, so it's going to be qualitative, and it's not going to be ranking them in any way, so it's going to be nominal, qualitative and nominal.